Welcome again. I am continuing this GHPython node. What do I call it? Uh, GHPython node Revit2021 Grasshopper Rhino3D at Wickerson Studios, and I'm into the surfaces still. And I am opening in Revit 2021 Rhino, work in process, opening Grasshopper, and in turn opening the Revit tools that exist here, dealing mainly with the params off of the start, with adding beams, and I think adding columns. No, I added beams. I just follow a column pattern, so you can play with those geometries a bit. If you're looking close at the Revit, you'll find these are I-beams in here, and this slab is actually built uh, directly into Revit. So you've got a bunch of ghosted forms from Grasshopper within Revit, and it's just a mix of everything, and it's also including a small script for dividing surface and putting cones on it. But I thought in doing so, I could also pull some additional data, a point list, and then generate a post node, GHPython node. I could generate some lines post nodes, which are kind of awkward here in the sense of how they I'll just rotate this as they come through the bottom of the form. The reason I do that, I elongate them, and I was playing off of different slabs that I can bring into here and play with the thickness of those. So it's a little bit of everything. It's kind of like a soup. So I'm excited enough about that, and I'll show you what I'm basically doing. And of course, it's all dependent on a Rhino surface. So if I went into the Rhino surface and alter the physical surface that's been imported, you can change the actual design. You could rotate that in a sense, maybe in this direction. See how that affects the whole drawing. So you're working and honestly, you could go in here and edit the points and grab a couple, which is nice because they're ghosted on top, and lift that up, and that would update in Revit as well. So really having a little bit of fun with this. What I started with was bringing in, if I take off my Grasshopper, I brought in a surface. Fairly simple through going into surface tools, surface creation, and I believe I went down here and chose the rectangle plane. Once I brought that in on the base surface here, I typed in rebuild, and I had then decided that would be the item I'd rebuild, and I brought in control points 5 by 4 in the U and V directions. I edited those points and did a simple surface edit, and I ended up with that shape. After I have that shape, I import that into the Grasshopper surface right here, and at the same time just take that visibility off. So that little canopy area is pretty nice, and then I ran that into a GHPython script, and in doing so I had to set height and radius to hint floats, and I set division, U and V division, to integers, which are parametric as well. So as we go into there and you take a look at what we actually have, you can play with those U and V divisions, and even though they're the same number, you could have many, you could have few, and they update in Revit after they update in traditionally how it works in Rhino. And then the height and radius I kept the same just for fun, so these would be interesting. And I think actually I would have fun with, let's take the height up by, let's just do a little multiplication here by math. So I do some pre and post Python nodes as I get better and better at scripting. Obviously, all of this can be tucked into there. So I'm going to multiply that by an integer of 3, and then height will be a little altered to the radius, and there you go. And actually, that's completely opposite what I wanted to do. I wanted the radius brought into that, and the height brought in as that. So you've got these kind of umbrellas, which is kind of fun. You have to hold down Shift and middle scroll button to rotate in Revit, whereas in Rhino, you can just use your right mouse button. So you kind of get this kind of orientation. I kind of wish that was the same, so I could navigate the same, but I guess people who are used to Revit, you slowly, it becomes second nature in your mind. You stop thinking about these things. And, that's kind of a nice parametric design on a surface you can control in Rhino from its actual original form. You can control it in your sliders going into your Python node. And what I did then was it generated basically the cones from this script. I'll just bring this up. The script is not too difficult. I'll show you what I ended up doing. I did the basic divide U and divide V of surface domains, keeping in mind that U and V are related to 0 and 1. DU and DV then become an average of domain U, 1 minus domain U 0, so that's the beginning and end of that line, and then you divide that by how many U counts there are, and then you do the same for DV. And then you have to make an empty cone list and an empty point list, and that will run through 2 iterations that are pretty basic using Rhino script syntax functions of evaluate surface, surface normals, plane face normals, add circles, copy object, extrude the point, and this is how you get the cone to work with this little section here. So this is additive from the last script I played with. But then you're able to take the cone list and append it with the cone in the point list and append it with the points, and then you output the cone list out and output the point list out, and just make sure you're typing that in here. Otherwise, you won't get in your Grasshopper, and we could just shrink this down here because there's nothing at the bottom of the script. We get a cone, which is nice, and there it is. And you can see that in the Rhino window. It, of course, highlights. It doesn't highlight in the Grasshopper window, but it certainly would update. Sorry, in the Revit window, but it certainly is visible in the Rhino window. And then what I did was just a simple point output and just had a little parameter that I could slide those I-beams up and down, as you can see, and make them longer and shorter, dealing in whatever metric or imperial system you're in as units. And of course, that's not ideal. It's something to start with. As I go in here, and I must be in a command whenever that happens, so I need to get out of this hide object. Whenever I think I bug out, it's usually because I'm in a command line in Rhino, and that can be very frustrating. So you need to be able to see that command line. So can't help you with Mac right now. I'm going to be using Windows to do that. Hold down Shift and then rotate up, and you see those I-beams come through the bottom of my slab. And that slab itself, this one's missing because I rotated that original surface. You'll remember at the beginning of the video. But this slab is actually going in and using the edits and getting a type of a generic 12-inch instead of a 6-inch slab. You can go in here and actually do some editing and go deeper and deeper into the editing and come up with whatever you want in detail. Now, I'm not that wise to it, so I'm not even going to bother. I'm going to use a lot of defaults for a while as I test my geometries in Revit, and that's really what this is essential to do. For those that have been freeform playing creatively in Rhino, Revit's going to make you be a lot more sensible. Certainly, if you consider the full scale of this, and I-beams can only be produced at a certain scale and size and accessible for you to use, this is a wonderful way of testing a CAD program that's possibly parametric in Grasshopper, testing that and running that in Revit to see if it's even feasible or possible to begin thinking of manufacturer fabrication. So this has been the key. This has been the missing link between trying to teach Rhino and sculpture to sculpture students. How can we actually get the process of, not just sending watertight meshes to the printers at a certain scale or sending things to CNC router or to the mills or to the laser cutter. This way we can actually start to dream and take our models and studies and sculptures and put them more on an architectural scale, which could be very creative for some, and hopefully some people will, realize there's some value in the visual arts when it comes to designing and programming and engineering and architecture. That's my goal, at least for now. We'll see if it changes by tomorrow. Anyway, all I did was throw in that one little node here, which came out of, like I said, almost the first parameters that are in Revit, the build parameters, add beam. What's nice is you could add a column, which would keep it straight, and they only work on the verticals, so you definitely could grab the column and put it in here and jump that in here, and you'd have the same thing happening if I took that off. So I still have the same generation of what's happening there. But what I liked about, if I could go back, this form instead was now, as I bring that form down and move that point down, and I use the beam, I could really start doing some post-production that maybe I don't just want to shoot that down in that direction, move that point in that direction. Maybe I want to swiggle it down using sine or cosine curves or different maths. Instead of making a fool of myself trying to figure it out, which usually isn't too hard, that move's got to go through a range of those points moving down. So if I move them down in a motion and decided, let's just take this off, well, we're going to be moving in a negative direction. And let's just see if we can do this. The vector is moving in a z direction, but what happens if we move it in a pattern going down from a range? This is going to be interesting. What if I move that in a range of points? Range. Oh, I don't know if I'm going to be able to wrap my head around this. I'm going to try. If I move that down in a range of points that move from 0 to 100, and the direction's not there yet because it's not a vector, what if I create a vector? Oh, this should be interesting. This could be interesting. What if I shot it in here and tried to take that vector out? Oh, this is going to be tricky. What if I took that range and put it in there? Oh my gosh. And started bringing in my maths, sine. Oh, this could be interesting. And the y and cosine in the z. This is like one of my favorite scripts to do. And anybody who knows me knows I just keep coming back to it. I'm so simple-minded when it comes to this stuff. I don't know if I'm producing all different vectors as it goes through. Perhaps I shouldn't be moving it. I mean, that's a vector that has to be created by points. Probably makes more sense. And I've just got to sit and wrap my head around this a little bit. The point system of x, y, and z. That's going to give me a series of points that comes down in a move, in a motion. Let me just think about this. Let me just think about this for a second. I'm going to hit hesitant, see if I can work it out, and then I'll finish up the video. It just takes me 5 seconds for sound. I'll show you exactly what I was trying to do. I was taking that point, and I basically wanted to run it on those points that were being generated in Rhino and in this system. And you can see here, it's not going to work. Obviously, the I-beams are like not going to do what you want to do. And the reason being, I-beams have to stay to a kind of closed planar, I think, curve that's like straight section or arcs. So when I start to throw that through, I'm not sure why it doesn't work, and I'm still going to play off of it a bit. I don't think that has to be graphed. You can see that the I-beams are basically generated, but the curves that I'm generating here, that's an old technique of just moving a point down. So that's all I really did, was just found a point system from my original. It doesn't matter where you make it. I made this original kind of curve here, moved it down in the z direction 100 points, and then multiplied the sine and cosine by and the steps, of course, can change. I can put it in like 12 steps, and I can move that up to 100. You see the effects on this. I can bring up as many of these as I want to articulate. You can see the I-beam doing these weird things. Now I'm expecting that curve to be able to be inputted directly into this Revit node, and this is where it says, Michael, you're being too foolish, and we're not going to make an I-beam like that. And the reason being, I don't have it on this page. Let me bring it over here and click here. Rhino Revit GH curve must be C1, continuous planar or non or closed curve. So that kind of tells me, I think it should say, it says C1, but I don't know why. I think C1 is, I guess, like G1 or G2 or G0. And I assume it has to be like sections or arcs, and it just won't wobble the I-beam the way I kind of want it to in here. So yeah, that's where I push my scripts usually too far, and it's like, no, we just want to move it down in a straight line or plug in a column to that system. And it seems to be holding the past object that was there, even though it's out of my script. It's not running. So that's really where I want to kind of show people that you can come at these from so many different angles. Let me make the mistakes for you, because as you see kind of a creative process, and I'm clicked on the surface there, but if I just leave, I should be able to just drag that down. Anyway, I'm still working on it. I think if you want to do some fancy work, you've got to get into different Revit parameters and things that can do things for you. But it will make you a little more conservative in how you're behaving, certainly in Rhino. And that's really what I'm hoping to bring to my sculpture students, is we're not just sitting painting on the screen and making these non-realistic forms. We're actually trying to bring things out into the world. And I hope that makes a little sense. I hope people find that interesting. We're under 10 minutes, or maybe we're 18 minutes for all I know. Thanks very much for watching.